Minasan.
Konnichiwa, or konbawa, depending on when you watch this video.
Hello everyone, my name is Diandra and I am here with my classmate Asuka. We are from 12A from Middle School Bekasi, and as you guys can see on my slide, we are here to present about COVID-19 exponential graph, specifically in Japan. Next slide. Here are the table of contents. First of all, I'm going to explain briefly about exponential growth. Afterwards, I'm going to explain about the basic formula of exponential growth and the pros and cons of exponential growth. And my classmate Asuka will explain about the COVID-19 graph and data in Japan. Without further ado, let's move on to the next slide. To understand about it, I'm going to define the word exponential growth for you. Based on Google, exponential growth can be defined as growth whose rate becomes ever more rapid in proportion to the growing total number or size. And here, you can see the basic formula of exponential growth and what makes the function or equation different from linear or quadratic or other functions is that the value of x is squared. The characteristic of this graph is that it has an asymptote, which are set of values that can or will not be equal to a certain value, but it may approach to that specific value. And as you guys see on the slide, exponential growth values are always increasing, and it will not flatten. And the opposite of exponential growth is called exponential decay, where the curve is decreasing. And next slide. Based on Blake Benverlow in his article entitled Modeling COVID-19 Spread in Canada as Exponential Growth, he modeled an exponential equation for COVID-19 in Canada. And although he analyzed it for the model of Canada's COVID-19 cases, it also can be applied to Japan's COVID-19 growth. And let me explain what are these variables. A, C, D, and B are constants. These constants can be changed to fit in the curve based on the plots of the values, while E is the natural number. The formula of the COVID-19 growth is equals to A times E to the power of C times X minus D plus B. The Y, or the Fx, represents the number of confirmed cases, where the X is it is the time of the COVID-19 cases. And moving on to the next slide, let me explain briefly about the pros and cons of the formula or of the graph. The pros is that, just as I mentioned before, the values of the constant can be adjusted to fit in with the curve or the model, while the cons are that the values might not follow the trend. And what I meant by this is that the shape of the curve might not be exponential. It can be other kind of shapes. And the second one is that if there are too much outliers, the curve may not be accurate or representative enough. That yeah, that's all from me. And next up, my classmate Asuka will explain further about COVID-19 case in Japan.
Okay, so now let's get into the COVID-19 cases in Japan, or the country of anime. As in today, when we record this, which is on Sunday, 28th of February 2021, Japan has 430,539 confirmed cases with 7,807 deaths and 408,020 recovered. For the purpose of this task, to make the graph easier to plot, we decided to use a certain period of time. So for the graphing of the exponential growth, we using this data, where X is the weeks, which starts from October 5th of 2020, and Y is the new confirmed cases of each week in thousands. And then we plot this graph. So we first plotted the points of the data previously, and then we can apply the formula that Diandra mentioned before to fit the points in which we got that equation, which is y equals to 2.7 times natural number to the power of 0.7 times x minus 5.1 plus 3.4. So the graph of that equation touches almost all points except for the third week and the sixth week. But the third week isn't far off from the graph, so I wouldn't consider it as an outlier. But the sixth point or the sixth week is. So I would assume that the sixth week as an outlier. The graph itself shows an exponential growth of the confirmed COVID of the new confirmed COVID cases in Japan from October 5th, 2020 to November 16, 2020 in weeks. If we see from just a graph alone, or if we rely on this equation, we would assume that the number of confirmed cases in Japan would still be increasing over time and quite a fast rate because since the graph is quite steep, so like going further there. But if we observe the official data from WHO beyond November 16, 2020, we can see that our assumption is more or less correct. I mean, yes, the cases do increase, here increase, but the rate of increase in the next 6 weeks is not as fast as we would assume from the graph that we have made. But in January 4th, 2021, which is this one, it shows a significant increase until it started to decrease in January 18, 2021. And starting from then on, the cases keeps on decreasing and decreasing in each week. Honestly, I'm not quite sure what causes the decrease because from the research that I've done, Japan only started the COVID-19 vaccination program on February 17, 2021, which as comparison, our President Joko Widodo, which is also the first person in Indonesia to receive the COVID-19 vaccination, got it way back on January 13, 2021. But the cases in Japan seems to be dropping a month prior to their COVID-19 vaccination program. Meanwhile, in Indonesia, the number of the new confirmed cases only started to drop after the vaccination program. So we can't assume that the decrease is caused by some kind of a vaccination. And my best guess is that the decrease is caused by some kind of a government program, like our PSBB, like the government program to decrease the COVID-19. And actually having this exponential model made is actually quite useful for cases like this. Like it helps to give some kind of an idea or like gambaran as to how much the number might increase in the future if no action is taken. So therefore, we can or the government can actually take action to prevent it from actually getting higher, the number. And actually, that's it from us. This is the references that we use in this presentation. And yes, arigatou gozaimashita. Thank you.